Yeah, so the thing about Bohr is that he was very involved with the future generations of physicists. And now, how dedicated was he? Okay, well,
Let's hear
so
it.
in 1916, he was offered a professorship at Copenhagen University. But at the time, the physics department at the university was very small. It was just like this tiny section of the university. And he was like, you know what? I will accept the professorship and all that stuff, but I want to build an institute for theoretical physics at this university. And his demands went through, and the university built the Niels Bohr Institute of Physics. I think the name changed over time. Now it's just called the Niels Bohr Institute. I think before it was called like Institute of Theoretical Physics, something like that. And what he did was he hosted a bunch of up and coming physics students from, I think, mostly around Europe, and a little bit, a few students came from America, but it was really like the top students that came to this university. And this is a crazy move for Bohr, because he said, you know what, people can be smart, right? You can think of smart ideas, but the way you move physics forward is by connecting smart people together so that they can connect their ideas and move forward. Like where would your insert favorite physicist here, right, be without communication with the outside world? Peer reviews of their papers, and just chats about their ideas. Like, this is what I think about this, and then someone else pulls out and he's like, no, this is what it is, here's why, here's my experiment, all this stuff. So what Bohr did for the physics world is that he brought together the smartest physicists, the smartest students from all around the world to come study in one location and to just bounce ideas off of each other. And so this is not like an experiment or anything, but this is what Bohr did.
It's pretty cool.
And I think it opened in 1921 in March. So 100 years ago, a little bit more than 100 years ago now. But the thing with this institute is that it hosted a lot of students. For example, Werner Heisenberg, who actually went to this institute.
Classic.
And I'd love to talk about Heisenberg as well. But the thing about this institute is that a lot of the students, or I guess a few of the students, were working on quantum mechanics at the time, or I guess at the time it was called matrix mechanics. And then you had other professors in other locations that were working on wave mechanics. It turns out that matrix mechanics and wave mechanics are just two different ways of explaining the same thing, and they're actually compatible with each other, meaning that, like, if you add, like, if you do multiplication but you do it like cross and add, or there's different ways to multiply, but it all does the same thing. It's the same idea here. The students at the Bohr Institute, they were dealing with the matrix mechanics side, the more like the quantized explanation for what we see at a small scale. Nowadays it's just called quantum mechanics, but back in the day it was separated because there were different philosophies behind different ideas. Schrodinger, we should talk about Schrodinger actually.
Schrodinger is like also in this time period.
In a future episode.
All these guys are in this time period is insane.
Yeah.
Like, this time period, the 20th century is such a revolutionary time period for science. It's just crazy. It's just crazy. Yeah, sorry, continue.
And by the way, I should have mentioned this earlier, but if you're interested with all that we're talking about right now, I read a book called Quantum, I think like The Great Debate About the Nature of Reality by Manji Kumar. Crazy book. Goes through the entire history from beginning all the way to like the end of this like quantum revolution. Like starting with like, how did like this idea of quantized energy and all, like, why are things quantized at all?
Mm-hmm.
You start with the very beginning in the 1800s with Max Planck having discovered black body radiation, and then so on and so on. Einstein comes into the picture, Bohr, Bell, which we can talk
Bell's
about
theorem.
also.
Oh yeah, for sure we can.
All these things, they come together, and somehow we formulate this explanation, and this is where we are now.